Remember, hopefully you remember, we were doing things like simplify square root of -50. So before, we've done simplify root of regular old 50. You have to break that down. What do you break 50 down into?
25.
Oh, thank you. 25 times 2. It's just that now we have a -1 there. And remember, we picked 25 as opposed to like 5 and 10. We picked 25 and 2 because 25 is a perfect square. And we know what the square root of 25 is. What is the square root of 25? 5. Square root of -1. And then the square root of 2 we can't really do much to. So in this case, it would be 5i root 2. We also did things like this. Oh, what do I want? I forget what the one was there. Remember the rule, and if you didn't watch the video, here's the important rule you need to remember. For all of this I stuff, before you can, outside times outside, inside times inside for roots. But before you can do that, if you have a negative, you need to simplify that. You can't multiply negative roots. You can't divide negative roots. You have to simplify it first. So for any of these, add, subtract, multiply, divide, you need to get rid of that negative root first. And so that's easy to do. It's positive 5 times -1. It's root 5, root -1. What is the root of -1? It's I. You need to get that I outside. And of course, this is the same thing there, right? 5 times -1. Square root 5, square root -1. What's the square root of -1? It's I. And now, once you get it this far, and I ran out of room, now you can multiply what's outside times outside? I squared. Inside times inside. What is I squared? What's root 25? So our answer would be -5, right? You need to simplify these first. If you didn't simplify it first, a common mistake I see, people multiply this together and get root of positive 25. Root of positive 25 is 5. Oh, you get the wrong answer if you don't simplify it first. So you have to take the I out. That's what I mean by simplify. You have to take the I out. This is I root 5, I root 5. Then you can multiply that. So back a little bit ago, I don't know, a week or two or so, we had problems like this. That's not allowed, right? What I have there, it's not simplified. Why is that not simplified? You can't have a square root in the denominator, right? So this is not allowed. Do you remember how we got rid of the square root in the denominator? Right, yes. You multiplied both top and bottom by the root that you wanted to get rid of. So if I want to get rid of square root of 5, I multiply top and bottom by square root of 5. What do you get downstairs then? 3 roots of outside times outside, inside times inside. 3 roots of 25, would you agree? And so, what is root 25? So it looks like on the bottom I'm going to have a 15. I always like to just do the bottom first because that's where I have to get rid of the root. Make sure I got rid of the root. Then I'll do the numerator. Numerator, that looks pretty easy. Outside times outside, outside times outside, inside times, 2 roots of 5. 2 roots of 5. Can I reduce that? Can I reduce the 5 and 15? Say no, because one of them is inside of a root and one of them is not inside of a root. In order to reduce, they'd have to both either be inside or both be outside. So that is as far as I can go, right? See, we're not allowed to have a square root in the denominator. So we multiplied top and bottom by that thing we wanted to get rid of. Well, guess what? I've got a little bit of bad news. What is I again? What is I equal? Square root of -1. Oh, and what's not allowed in a denominator? A square root. So guess what else is not allowed in a denominator? I. I is actually a square root. Square roots aren't allowed in the denominator. So neither is I. You can't have an I in a denominator and be simplified. But that's okay. You know how to get rid of it. Remember over here, we multiplied by the root that we wanted to get rid of? We multiplied by the thing we wanted to get rid of. Guess what we're going to do here? Multiply by the thing we want to get rid of. What do we want to get rid of? Yeah. So all you have to do is multiply by I over I. In the bottom, what is 3I times I? I times I is I squared, just like any other variable. X times X is X squared. Y times Y is Y squared. I times I is I squared. What is I squared? I squared is -1. So in our denominator, we just get a -3. That's not too bad, right? What about the numerator? That's the easy part. What do you get? 2I, 2I, 2I. You can't simplify that at all, so that wasn't too bad. Just multiply top and bottom by I. You're not allowed to have an I in the denominator, so multiply top and bottom by I. Does that make sense? Do you have any questions on this one? Anybody? So again, I'm not allowed to have a root in the denominator. So there's a couple of ways you could do this. Remember over here, we multiplied by the thing we were trying to get rid of? So here, you could multiply top and bottom by root of -2. But remember, before you can multiply the roots of a negative, you have to simplify it. So you know what I think I would do here? I think I would 2 times -1. I think I would simplify it right off the bat. So 2 root -1. What is root -1? So I think I have 6 over I roots of 2. This one is sort of like a double whammy. What can't you have in a denominator? You can't have a square root, and you also can't have an I. That's why I said it's a double whammy. We got two things we can't have in a denominator. So, in order to get rid of the I, what will we have to multiply by? I over I. And in order to get rid of the 2, in order to get rid of the root of 2, we're also going to have to multiply by square root of 2, square root of 2. So you have to get rid of both of those things. To get rid of the I, you multiply by I over I. To get rid of the root 2, you multiply by root 2 over root 2. That's not too bad. You guys can do that. Outside times outside, I squared. Inside times inside, 2 times 2, 4. What is I squared? -1. And root of 4 is? So it looks like my bottom is going to be a -2. Agree? What about the top? Is this an outside or an inside? Outside. So 6 times I, and then inside with, there is no other inside, 6I root 2. 6I root 2. Done? Done? Yeah. No. If I had this, but they can't see it. If I had -6xy over 2z, would I be done? That's all times. I can reduce that, right? Well, the same is true here. It doesn't matter. This is all times, so it doesn't matter if I have an I and a root. I can reduce this. I can divide them both by 2. 6 divided by 2 is 3. -2 divided by 2 is -1. So I get 3I root 2 over -1. Isn't that just going to be -3I root 2? I would take this, though. I would let it go. You know, if I was in a good mood. If I was in a good mood, I'd let that go. If I was in a good mood, I'd let that go. You know when I'm in a good mood? Do you know when I'm in a good mood? Oh, that was the right answer. He's such a smart boy. Are you just saying that? I'm almost always in a good mood. Except for Sunday when my washing machine broke with a whole load of clothes in there soaking wet. That didn't make me very happy. Anyway, does that make sense? You have to simplify this first. Simplify 2 and -1. Root of -1 is I. Can't have an I in the denominator. Can't have a root 2 in the denominator. So we need to multiply by both of those because we have to get rid of both of those. Make sense? Mm-hmm. Questions on this one or anything else? Questions? Now we got to solve. I don't think you need me for this one. I bet you could solve it all by yourself. But I'll earn my pay today and show you how to do it. If you tell me what to do, what do I do first? What do I do first? Yeah, take away the 19. You want to get the variable term by itself. So -19 equals, what would that be, -16? Now what? I didn't copy that wrong, Did I? I didn't copy it wrong, did I? No, I didn't. Okay. Divide by 2, she says. Divide by 2, divide by 2. Now I have x squared equals -8. Square root. To get rid of the x squared, I'm going to square root. And really, when you're solving, and I'll show you more about this in 1 second, when you're solving for a variable of x, you really should take both positive and negative. And I'll tell you more about that in a minute. We need to simplify this root of -8. How can I break down -8? How could I break down +8? Remember my list over there of perfect squares? How do you break down 8? 2 and 4. Yeah, 4 times 2, and then it's negative, so I'll multiply it by -1. So I have root 4, root 2, root of -1. What is root of 4? What is root of -1? And then that root 2, I don't know what to do with it. X equals. So now we can get a solution. Remember before, if we took the square root of a negative, we would say no real solution. There still is no real solution, but there are some imaginary solutions. Does that make sense? Now, that plus and minus bit, what if I give you this? I probably should have told you this in the section before this, but that's okay. What if you have x squared equals 9? Well, you know how to get rid of a square. You take the square root, right? You take the square root. And so the square and the square root cancel each other out. And we would put down x equals 3. Remember, I want to know what number squared equals 9. Well, this is right. 3 squared equals 9. But there's also another number that if you square it gives you 9. What is it? Right. -3 also works. So only when you're solving these problems for x, when they say find x, that's when we want to consider what could x be? Well, x could be 3, but x could also be -3. So we should be considering both when we're solving the problems for x. We should be considering both the positive and the negative. If I just ask you what's the root of 25, you can just tell me 5. But when we're solving and I ask you, what could x be? Well, x could be the positive value, but x could also be the negative value. So we should put this plus and minus in here to show that it's both the positive and the negative. Does that make sense? It's not too bad, right? This imaginary world we've entered. Do you have questions? Are there any questions? Does anyone have a question? So I am on page 290 and 291. Page 290, 291, page 290, 291. WE. We left off at 21. I have 22 to 40. 22 to 14. 22 to 14.